I'm not gonna be here on Thursday again.
Stop. What is this? You're avoiding us. That's fine. I'll give you the notes today. The notes on Thursday are short.
This is gonna be the last time on block too. Like this is our last time.
Oh, good luck.
Hey, start district.
All right. Okay, let's go ahead and get started. So here's the deal. We have 2 notes left for this week. Okay, normally I would do the short one today and then the long one on Thursday, but y'all don't want to do long notes on Thursday. So our notes today are a little bit more on the tedious side, but that'll make Thursday an easier sort of right before spring break. Okay, so if you'll take a look at your notes for today. Okay, at the top, we learned how to solve separable differential equations last time. What would you do first? Okay, you have your dy dx is x squared over y. Okay, Dawson, let's put that away for now, please. Okay, so what would you need to do first? Okay, multiply the y and then multiply the dx. So remember, you want all the y stuff to be over here, all the x stuff to be over here. So your y is going to go to this side. Your dx is going to go to this side. So here's what we have now. Y dy x squared dx. Okay, so step number 1, you're going to separate. What's step number 2? Antiderivative. Very good. Okay, then what is the integral of y? 1/2 y squared. And then what about on your x squared? Okay, great. Thanks. Plus c. Okay, then from here, remember, we want to get our y by itself. So how do I get rid of that 2? Okay, I'm going to times by 2. Now remember, technically I'm timesing 2 everywhere, but since I already didn't know what the c is, we're going to just continue to call it c. So this is going to be a y squared only, and my 1/3 times 2 is now a 2/3 plus c. And then last step, take the square root. Okay, remember, for a square root, you should do a plus or minus. So our general solution is plus or minus the square root of 2/3 x cubed plus c. Now, out of those options, which multiple choice answers can we get rid of? Oh, look, all of them. Almost, actually. Okay, we will eventually be able to eliminate C and D. Okay, how will I know that this negative has to be in the front? Look at the ordered pair they gave you. If y of 3 is -2, then -2 needs to be the answer when you plug in the 3 here. Okay, but then remember what we talked about. If I'm trying to match this y value, I have to pick the negative that comes in the front. Okay, which pretty much eliminates. So it would have to be. Okay, but for most questions, you would have to actually find the C yourself. You just, by process of elimination, don't here. Okay, easy? We remember it? Maybe not easy, but you know how to do it a little bit? Okay. So our goal today is to tie this into something called the slope field. Okay, slope fields are a little bit tedious, but overall, they should not be super hard. So let's take a look at number 1. The first thing I want you to notice is that you have a dy dx equation. Okay, remember that a dy dx equation is called a differential equation because it already has a derivative. Okay, from there, you're going to take every ordered pair on this grid and you're going to plug them into the dy dx, and then you're going to draw a line segment representing the slope of the graph at that point. So that sounds really confusing, but I want you to group the points into their x value. So what I mean by that is every point in this line has what x value? So this is 2, 0. 2 comma 1, 2 comma 2. What is everybody in this line's x value? 2. So I want you to put everything here has an x value of 2. Everything here has an x value of 1. Okay, then when I get to the y-axis, that's an x value of 0. Everything in this column has what x value? Negative 1. And then everything in this column has an x value of negative 2. Okay, then we're going to take turns plugging in the x into the differential equation, and we're going to draw a slope representing that steepness. So let's start with 2. Plug in a 2 right here. What's 2 minus 1? Then I want you to draw a slope of 1, which should be an uphill perfect diagonal. Okay, now we're going to scoot over, and we're going to plug in what x value for this column? 1. What is 1 minus 1? 0. And what does a 0 slope look like? Flat or horizontal. So draw in flats all the way down that column. Okay, the next x value I'm plugging in is 0. And I'm plugging in 0 to x minus 1. What's 0 minus 1? Negative 1. So I want a perfect diagonal, but downhill to show a negative slope. So it should be like that. Okay, we're going to scoot over one more. What's my next x value here? Negative 1, but when I plug it in here, what is negative 1 minus 1? So now your slope should change from negative 1 to negative 2. If this is a perfect diagonal, should it get flatter or steeper in this one? Steeper, so you want it to be maybe like that. Okay, then if I go over one more, now I'm plugging in an x value of negative 2. What's negative 2 minus 1 more? Negative 3, which would be even steeper than that. So it'd be, okay. We're going to go ahead and do one more slope field before we do the solving here on the right-hand side. So for my next slope field, you'll notice you have another little spread of points. Okay, and what is our dy dx or differential equation equal to? X squared. So let's start with 2. Okay, this is x equals 2. What is 2 squared? 4. So I want you to draw a steepness of 4. So it should be pretty steep, and it's going to be uphill. What are we plugging in next? X equals what? 1. What is 1 squared? Still 1, and 1 is a perfect diagonal. So you want it to be like that. Okay, next we're plugging in the middle would be x equals what? 0, and what is 0 squared? So it'd be perfectly flat. Going over one more. Now we're plugging in negative 1 for our x. But what is negative 1 squared? Positive 1. So I should have perfect uphill diagonals. Okay, and then more or less, obviously it doesn't have to be perfect, but this column and this column should have the same steepness because they both have a slope of 1. Okay, last one over here, we have a negative 2. What is negative 2 squared? 4, so it should be the same steepness as this column. It doesn't have to be perfect, but just do your best. Okay, so now let's talk about what does that have to do with what we did last class. So I want you to pretend that we didn't do this and that I asked you last class to solve this. Okay, here's what you would do. Step number 1 is you would separate. Now, when I look at this equation, I notice that I don't have any y's to move, but I do have a dx that's on the wrong side. So let's multiply our dx up to the other side. So now I have dy equals x minus 1 dx. Now, because the dy is by itself, we're going to call that a 1 dy. And then what's the next step for me to solve? Integral or antiderivative on both sides. Very good. Now, when I integrate 1, keep in mind that I'm on the y side. what is the integral of 1 going to go back to? Normally it'd be x, but I'm on the y side. So it would integrate back to a 1y. And then on this side, what's the antiderivative of x minus 1? Let's go one term at a time. Let's do the x first. 1/2 x squared, because I bumped the power up and then divide. And then my minus 1 would go back to a minus 1 plus c. Okay, that's your general solution. Okay, now let's do the one right below that. So I see my dx is on the wrong side, but there are not any y's that I have to relocate. So I have a 1 dy, and then I have an x squared dx. Integral. On the left side, I'm integrating a 1. What does 1 go back to? 1y. And then on the x squared side, what's the antiderivative? 1/3 x cubed plus c. Okay, here's the connection. What shape does an x squared graph have? Okay, a U or a parabola, that's right. And what does the plus c do to the parabola? It shifts it up or down. So if you look at your slope field, say that I want to do the solution through 1, -1, then if I go to 1, -1 and I sketch or kind of like connect the dots, do you see that it's the shape of a parabola? Okay, so this slope field is going to give you an outline for what the solution, if you solved it, would look like. Let's do the same thing on this one. You're drawing it through 1, 1 this time. So find that point on your graph. That would be here. And then follow the shape of the slope field. I'm going up. Then on this side, I'm going to flatten out and then go down. And do you notice that this is the shape of a what? An x cubed graph should look like this. Just like an x squared graph should look like this. Does that kind of make sense? So the differential equation is going to give you the overall shape of the graph. Now, what if instead of me going through 1, 1, let's say that I went up to a different point. Let's say I went up to here. Well, then now it's still going to be the same shape, but it's just going to be shifted up 1 from that original point. Okay, so no matter what my C is, that won't change the shape of the graph. It'll just change how vertically it's shifted. Okay. All right. So that being said, go ahead and turn the page. Okay, we're not going to do any more solving. Okay, we're just going to do the slope fields, but that's kind of the connection. Okay. So on the next page, we have a dy dx, but our equation is a y minus 2. So instead of it having an x in it, it only has a y. Then I want to group or cluster my points based on which points have the same y value. So instead of me doing columns, I'm going to break my graph down into rows. So what I mean by that is every point on this row has what y value? Everyone on this row has a y value of 0. Okay, what about every single point in this row? What are their y values all? 1. Okay, then if I go up one more row, all of these y's are 2's. Everything above that is a y value of 3. And then the very top row would be a y value of 4. Okay, then if you want to fill in these bottom 2, every point in this row has a y value of -1. And then below that would be -2. Okay, let's start with 4. If I take a y value of 4 and I plug it in here, what would 4 minus 2 be? 2. So I want you to draw an approximate slope of 2. It should be uphill and a little bit steeper than a perfect diagonal. So draw it in like that. Okay, next I'm gonna go to 3. I'm gonna take my y value of 3. I'm gonna plug it into this slope field differential equation. What's 3 minus 2? 1. Then these should all be perfect diagonals uphill. Next, I make it to 2. What is 2 when I plug it into the differential? 2 minus 2 is 0. Okay, next we're going down to 1. What would 1 be if I plug it in here? 1 minus 2 is -1, which is a perfect downhill diagonal. Go down one more for that. It's 0 now minus 2. What's 0 minus 2? -2. Should it get steeper or flatter? Steeper. And then if I go down one more, I'd be at -1 minus 2, which now is a -3. This row should get even steeper and then steeper. Okay, so you can kind of identify the patterns as you're going through it so that hopefully you won't have to plug in every single point. You can just kind of see, oh, as I get away from 2, my graphs should be getting steeper downhill as I go down or steeper uphill as I go up. Okay, and then we're not going to solve. Okay, so let's go ahead and do number 4. Okay, y squared. Okay, let's plug in our top row first. What are all the y values in this row? What number? 2. And what is 1 over 2 squared? So when y is a 2, my slope is a 4th. Because it'd be 1 over 2 squared, which is 1 over 4. So draw in pretty flat uphill slopes. Because remember, 1/4 is like rise 1, run 4. So those should be pretty flat. Okay, next we're going to this row. What's our y value? 1. And what's 1 over 1 squared? So when my y is a 1, my slope also comes out to a 1. How do I draw a 1 slope? What should it look like? Perfect diagonal uphill. Okay, the next row I'm on is the x-axis, which is a y value of 0. And what happens if I do 1 over 0 squared? That would be undefined. Okay, remember, a 0 on top, that would divide to 0. But a 0 on bottom, you can't do that. So undefined, you're going to leave that whole row blank. Okay, you're not going to draw in actual vertical lines. Okay, you're going to leave it blank. Okay, next row is a -1. What is 1 over -1 squared? +1, very good. Okay, and notice the -1 is going to, when it's squared, it'll turn positive, and divide 1 with itself, it would stay. So perfect uphill diagonals. And then next one, we're doing -2. That'd be 1 over -2 squared. But what is -2 squared on the bottom? 4. So it'd be 1/4, which means that my graph should go from a +1 slope to a 1/4 slope. Now, if I went 1 further, my y value would go to a 3. 3 squared is 9. A 9th would be even flatter than that. Okay, so then you can just kind of picture what it would look like without necessarily plugging in everything. Okay, so let's make some conclusions before we get to worse ones. Okay, if your differential equation down here at the bottom, if it only has x's, your slope field is going to have columns. Okay, because columns have the same x value all the way down. If your differential equation only has y's in it, you are going to see rows of the same slope. Okay, so the front was in columns because my equation only had x's. Okay, this page was in rows because I only had y's. Okay, next thing, the differential equation is gonna outline the shape of the general solution. Okay, so if you did separable differential equations and you solved it, okay, whatever the shape is of the graph, that should match the shape of your differential. Okay, if you get a dy dx of 0, you would have a horizontal slope at that point. If your dy dx comes out to be undefined, remember that's a number divided by 0 on the bottom. You are going to leave those blank. And then if you get a 0 over 0, that should also be left blank. Okay. So for verticals or undefined slopes, blank. And then if you get like a 0 over 0, you would leave that blank as well. Okay, so turn the page. Hopefully we can do just only maybe 2 of these all the way through. So I'm going to give you like a process for these that I think will make this a lot easier in terms of like organizing your work. So here you'll see that we have a huge spread of points, and we're going to have to plug in every single point to this equation and then draw the slope. So you want to be methodical, or this is going to take 100 years. So the first thing I want you to tell me is, what would my y have to be for this equation to come out to be 0? What number would y have to be to make that equation come out to a 0? 2. So I want you to put that I'm going to have a 0 slope anytime that my y is a 2. And then I'm going to find all of the points on my graph where my y is a 2, and I'm going to draw in my flats. So this is 0, 1, 2. All of these should be flat. Okay, is there any number that x could be that would 0 out the whole equation? Okay, x could be 0. So I'm going to put and x equals 0. And now x equals 0 would be a column. So I'm going to go flat, 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 flat. So all those points are done. Okay, out of the points that are left, I want you to start with our 1s. So this is 1, 0, 1, 1. I'm going to skip 1, 2 because I already know it's flat. And then 1, 3, and 1, 4. Okay, so the points that I've just written down are this one, this one, this one, this one. Okay, the 4 points in yellow. Okay, and then we're going to plug that x comma y into the dy dx equation. So remember, my dy dx equation is x times y minus 2. So all of those points, the x is a 1. So it's 1 times 4 minus 2, 1 times 3 minus 2, 1 times 1 minus 2, and 1 times 0 minus 2. Okay, what will my first value come out to be? 4 minus 2 is, times it by 1, it's still, put a 2 right there. Okay, then go to the graph and draw a slope of 2. Okay, it should be uphill and it should be steeper than a perfect diagonal. Okay, for the next one, what's this slope going to be? 3 minus 2 is, times it by a 1 in front, it's still 1. So I want a perfect diagonal there. Okay, next one. 1 minus 2, what is it? Negative 1, times it by 1, it's still a negative 1. Perfect downhill. And then for the next one, what will my slope come out to be? Negative 2, and I can see it got steeper. Now, you should notice that this pattern is going to continue. I had a perfect diagonal, then I got steeper. So for your next 2, go steeper, steeper. Okay, doesn't have to be perfect. Okay, then to be a little bit lazy, Okay, I just want you to take your one ordered pairs and change them all to minus ones. So minus one, minus one, minus one, minus one, which means minus ones in the front. What overall impact will that have on your slope answer? Just gonna flip it. So if it was originally a 2, now these are both negative 2s. And if it was a negative 1, now it's a positive 1. So now let's come over to the negative ones and draw those slopes in. Okay, so that would be these 4 points right here. So at negative 1, 4, my slope is a negative 2. That'd be downhill steeper than the diagonal. Negative 1, 3 should be a perfect negative 1 diagonal. Negative 1, 1 should be a positive 1 slope. That's an uphill perfect diagonal. And then as I go down to negative 1, 0, it's now a positive 2. And then remember, we said as we move away from that flat line here, these are going to get steeper. Okay, you don't have to perfectly measure it, just kind of estimate it. Okay. All right, then the last column we need to do is this one right here. So if this is 1, 0, this would be 2, 0. 2, 1. I'm going to skip 2, 2, because I already know it's going to be 0. And then I'll go to 2, 3, and 2, 4. Okay, my equation is going to be x times y minus 2. So it's 2 times 4 minus 2. 2 times 3 minus 2. 2 times 1 minus 2. 2 times 0 minus 2. Okay, then go ahead and calculate each of those slopes. And then you're going to sketch them onto your ordered pairs associated with that. So I'm talking about these 4 points right here. Find those values and then draw in that steepness that goes with it. So what will this slope be for the top row? 4. Okay, then come over to your graph. Now, if this is a slope of 2, 4 should be pretty steep. Okay, what about this one? 2. So should it get more or less steep than the 4 you just drew? A little bit less steep, but still steeper than a perfect diagonal. Okay, down here, what am I going to get? 1 minus 2 is negative 1 times 2 is negative 2. So I want it to be downhill, a little bit steeper than the diagonal. And then this one would be negative 4, which should be steeper, steeper, steeper. Okay, and you're just going to kind of follow the pattern as you go down. Okay, then switch these 2's to negatives, switch your signs here, and fill out your last. So if this is now all minus 2's, then my top 2 will come out negative, my bottom 2 will come out positive. So at negative 2, 4, I'd be negative 4, negative 2. Down here, I'd be 2, 4, and then they should get steeper. Got it? Okay, we're going to do one more all the way through, and then hopefully we won't have to do any more all the way through. Okay, look at number 6, and I want you to tell me what would X or Y have to be to make it 0 or flat. If my Y is a 3, where is my 0, on the top or the bottom? So if my Y is a 3, that's going to be an undefined slope. And remember, for those, I'm going to leave it blank. So find your Y equals 3 row. So this is 1, 2, 3. All of these you're going to leave blank. Okay, what would X have to be to give me a 0 slope? 0. So my 0 slope is going to be whenever my X is 0. Okay, because if this is a 0, it doesn't matter what I divide it by, it's going to stay a 0. So go to your column remember, you never write on a blank. So because this row is blank, I would not put a 0 here. Okay, and then remember, our goal is to just try to find enough points that we can finish the pattern. So I'm going to do the same 4 dots here, but this time, instead of skipping my 2 row for the Y's, I'll skip my 3's. So I'll do 1, 0, 1, 1, 1, 2, and then I'm skipping the 3's because I know it has to be blank, and then I'll go to 1, 4. The equation that I'm going to use to find my slopes is going to be x over y minus 3. So in this case, it'd be 1 over 0 minus 3, 1 over 1 minus 3, 1 over 2 minus 3, 1 over 4 minus 3. Okay, on the bottom here, what's 0 minus 3 for that top one? -3, so it'd be 1 over -3 or -1/3. Very good. 1 minus 3 here, what's the bottom? -2, so it'd be -1/2. Okay, and then let's go ahead and draw those in. Which one should be steeper, -1/3 or -1/2? -1/2. So -1/3 should be pretty flat downhill. Oh crap, I drew that in the wrong spot. 1, 0 should be here. Don't do that. Really flat. Okay, then not quite as flat. What would 1, 2 be? Or sorry, yeah, 1, 2. What would this come out to be? -1. So that should be a perfect downhill diagonal. And then my 1, 4, this is the one I messed up on. We're going to have to fix it. 4 minus 3 comes out to a 1. 1 divided by 1 is an uphill 1. So it should be like that. Okay, then remember our little trick. Okay, and we're going to just look for the pattern. So as I went down, what was happening to my slope? It's getting flatter. So just keep it getting flatter as you go down. So it'll be flatter, flattest. Okay, then to be a little bit lazy, you're just going to change all your 1's in your X column to be -1's. Which means that these are now all -1's on the top. And that's essentially just going to flip these signs. So now it's a +1/3, +1/2, +1, negative. And then you can draw on your other side. Okay, and what you should notice is that basically the steepness here is going to mirror the steepness here. It'll just be the opposite way. So this was a perfect uphill diagonal. Now this is going to be a perfect downhill diagonal. This was a perfect downhill. Now this is a perfect uphill. And then remember, as I move away from that flat blank spot, okay, it should get flatter. So I'll go flatter, 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 flattest. Okay, so 4 more left. So we're going to have, this is 2, 0, 2, 1, 2, 2, and 2, 4. Okay, but remember, we're skipping the 3rd row because we know it's going to be blank anyways. So this would be 2 over 0 minus 3, 2 over 1 minus 3, 2 over 2 minus 3, and 2 over 4 minus 3. And then you'll just like find those and then map them onto your thing. Okay, so what will this first one be? -2/3. And then go to 2, 0. That would be right here. And you're going to do a -2/3 slope. Now, comparing, if this is a negative 1/3, negative 2/3 should just be a little steeper than that. Okay, 2 over 1 minus 3 is going to be 2 over negative 2, which is negative 1. So this should be a perfect downhill. Next one, 2 minus 3 on the bottom is a negative 1. Divided by 2 is going to be a negative 2, which means that one should be steeper. Okay, we're skipping our blanks and going to 2, 4. 4 minus 3 is 1. Divided under a 2. 2 divided by 1 is 2 up. And then based on the pattern that I saw on my 1 and negative 1, I can kind of repeat that on 2 and negative 2. That the steepness here is going to be the equivalent steepness, but instead of uphill, this side should be down. So this should be a negative 2. This should be a positive 2, positive 1, positive 2/3, and then flatten as you go down. Okay. Questions on that? Okay. We are not going to finish out the next two, but I want you to find your flats and your verticals. So look at the next one, look at your equation, and I want you to write when it would be either vertical, meaning you leave it blank, or horizontal, meaning you would draw in flats. So take a look at number 7. Do we need this up here longer? So for number 7, you're finding your zeros and your verticals. Good now? Okay. What will make this a 0 slope or a flat slope? Okay, very good. If x is 0, then I should have flats. What will make it a vertical or undefined slope? Y is 0. Because remember, if y is 0, that's going to 0 out the bottom, and no, you can't have a 0 on the bottom. So that means that all of these points need to be left blank. And if it's a flat versus a blank, who wins? Blank. So get rid of the 0. Okay, if it's both, the blank wins. All right, go to the next one. What would have to happen for that to be 0 on the next one? Very good. Okay, the x and the y would have to equal each other. And where does that happen on the graph? Origin 0, 0, where else? 1, 1, where else? 2, 2. Okay, -1, -1, and -2, -2. Okay, then for the remaining points, you would do it just like we did it on the other one. Take the xy, plug it into the formula, draw an approximate steepness of that number. Does that make sense? Okay. So go ahead and turn the page. We're going to practice normally on the AP test. There are 2 ways that they're going to test it. Okay, the first one is that they're going to give you a graph and say, draw the slope. Okay, we've covered that. The second one is they'll ask you to match which differential equation goes with which slope field. So I'm going to show you how to do that. Go ahead and take a look at your next page. You have 6 equations across the top, and then you have 6 differential equations. So let's start with these 2. Identify what would have to be true for these to be flat. So for the first 2, because they're almost the same thing. What would x or y have to be? Okay, who would have to be there, x or y? So my 0 slopes are going to be when y is 3, or what else? Not x3. X could be 0. Oh. Yeah? Because if the x is in the front, then whatever I times it with, it was 0 the whole thing. So look at your graphs. There are 6 of them. Which one has all flats through the row y equals 3 and the column x equals 0. So it's either going to be the top row, the middle row, or the bottom row. Ooh, you want to close that? We can close that. Okay.
It's like raining last night and it was.
I know.
Sky. I heard some house is on fire.
What? By an electrical line breaking? That. Okay, secretly, I hope that our school got messed up, so that we wouldn't have had to come, but here we are, so. That is true. Okay, so which row, the top two, the middle two, or the bottom two, have the flats in the right spot? Not the top two. The middle two. Let's show where they are. Okay, on this one, do you see that all of your flats are through y equals 3? Do you see that? Okay, and then also down through your x equals 0, do you see that you have all your flats there too? Okay, so the flats will do half of the work for us. Okay, that we automatically know these have to be a match with the first two. Here's how you're going to finish it out. Pick a test point where the slope fields don't have the same direction. So I'm going to use 1, 1. Okay, on this graph, at 1, 1, is this slope positive or negative? How do we know it's negative? Which way is the little line going? Downhill. On this one at 1, 1, which way is the line going? Up. So what you're going to do is pick your test point, and then if the slope comes out negative, you know it's this one. And at this one, if you plug in 1, 1, it should give you a positive slope. Okay, so take a look at the first differential equation. It was x times y minus 3. I would do 1 times 1 minus 3. How is that going to come out? Negative. Then this one has to be a match for this graph. Does that make sense? So put dy dx equals x times y minus 3. Okay, and then if that's the match for the first one, then you kind of automatically know that the second one has to be negative x, y minus 3. Now, just to double check, go ahead and plug in your 1, 1. If this is a negative 1 times a 1 minus 3, the negatives will cancel out and they'll give me the positive that I want. Okay, so those two are done. Okay, next two. We have an x minus 2 over y. Okay, x minus 2 over y. Where are your flats going to be? Okay, so it's going to be where your x is a 2. And then it'll be undefined when what? Y equals 0. So look at your top row or your bottom row. Okay, which one matches that? I need flats through x equals 2, and I need blanks at y equals 0. Okay, it should be the top row. Here are your flats. And then here are your blanks. Here are your flats. And then there are your blanks. Okay, then remember to finalize your matching, you're going to choose a test point where the little lines aren't going the same way. So it doesn't have to be 1, 1, but I am going to use 1, 1 again because this one's uphill and this one's downhill, and they're like pretty easy numbers. So if I plug in 1, 1, how's this one going to come out? 1 minus 2 over 1. Negative. Then this one has to match which slope field, 1 or 2. If the slope came out negative, who does it have to match? 2. So your dy dx here would be negative x. Oh, wait, no, wrong. x minus 2 over y. That means that this one would have to be the negative x minus 2 over y. Okay, and then if you're not sure, plug in the 1, 1 and just check that the line's going the right way. 1 minus 2 would be negative 1, but then when you multiply it with the negative in the front, it would cross out and give you a positive. Okay, let's talk about the last two. Okay, they're both sine x. Do you see that these are both doing little wavies? Okay, like they're a trig function, yeah? Okay, so think about, if I start with sine, okay, which way should the wave be going? Or actually, let's do this. What's the sign of the first finger? So, okay, at 0, it's 0. What about the next finger? It would be 1/2, yeah? Okay, and then what about like the sign of 90 degrees? You'd be at 1. So your initial values should be positive. Okay, and you can tell on this one that this one starts uphill. So this would be your dy dx of sine x. But we know this is positive sine x because it starts out with positive slopes, just like the initial values of sine are positive. Okay, and then this one starts out downhill, which means that it's negative sine x. Okay? All right, so here's what I want you to do now. Turn the page. You have one more. It's 8 graphs, 8 equations. Try to match them up. Okay, and then we're done with notes. Okay.
Sure, all those later.
You did? Wow, no, I didn't know that. All right, let's match them up, and then you're done. Yeah. Okay, will you email me? And just tell me that?
I don't know. I think they broke up. They're like, oh, there's a straw. Yeah, I know, right? A straw. In the water.
All right, guys, let's start matching. Just have a little caffeine in it, you know? It actually is similar, but it doesn't have as much. No, I do not want to have a heart attack.
My monster is so good. I have one for every game.
Hey, that is so bad. Because it ramps your heart up and then you're running around and your heart.
No, I don't run around. I just like throw the ball. I saw Aiden's. I didn't know if that was you or not. Because they said your name. It's not my name. He put it on there.
Okay, so let's do this. We'll read this last. Exit 2. So this one has a column.
There was one else that said, current moment. There's no pencil.
Yeah, so it is a column, that, but they need to all be flat. If it's in yours. So these are all flat, you know what I mean? Those are yours. Okay, so you know that's a match, so put a V on this. Okay, then let's do these two. B and C.
Yeah, you have to like.
Choose for which letter.
So
Y. So look for, remember, if it's a hollow, it's an X. Okay, Y. So which one? Y.
I would've given it there.
I do give it to you.
Then you would? I said I would.
Oh, and you give it to him.
And they have to be flat all the way across.
What do you want from?
Go whole way.
The thing is, like, mine are like,
The first
oh,
one.
never mind this thing. I just want them.
You had
Like,
like.
I was gonna,
Yeah.
I was gonna
Yes,
do it,
that's what I'm
like, before the day, I can, today was the last day. But today.
Yes.
Was it last day?
So now the question is, which one is which? So we need to pick a different row other than two as our test row. So let's try this one. At 3 on this graph, what is negative versus on this graph, what is the 3 row?
Last
Positive.
week.
So we need to plug in a 3 to both of these and see how it comes out.
I was.
So 3 minus 2, how will D come out? 1 is positive, and I need to make sure that D matches with a row where the 3 row is up there. Which means the other one is.
You'd be better.
Make sense?
No. There, no.
Okay. Then let's find another one.
3 times. You think that's right?
Let's do this.
Okay.
Okay.
Drop me, spend this song 5 times.
X, Y is gonna be 0. Then.
I was you then, I hear it did.
All your
I'm flying in from the car. While I was driving, right? I was driving and flashing.
There's one of them on the bottom, so you can get it. Does that make sense? So which one? If it's a fraction, so like on this one, your Y was on the bottom, or what? That one did not have any blank?
Oh my God.
Because you didn't have to.
Oh my God.
Excellent.
Oh my God.
Okay, so which one has flat on the x-axis and flat?
I was the one that.
It's flat that way, but it's not flat this way. It has to be X and Y have to go here. Yes, that's fine. They would come to how they're flat, and then when they're on there, it's like, they're like right on top. That's what I'm like. This is like- Okay, so these, now let's take it. Like one. So what is one on? And what? If I plug in one, which of these is gonna be what? Does that make sense? And then the other one has to. Okay, then out of the other ones, let's do E to the X. Which of these graphs have? You see like we just kind of. Remember, we got it, differential equations, by the takeoff. So we only have 2 left, we have sine and then. If I plug in 0. And if I plug in 0 to cosine, everyone's one. So it has one.
I don't know. Here you go, making up rules, like we did when we played Clue.
Scratch it out, you should. You're talking like glue.
You're not like Clue, you know all
So
the
this
rules.
has to be your.
You like, it's funny, actually, it's like.
Plug in 0.
Oh, it's like I'm making up rules on the games and
For a perfect circle.
Fraction.
Does that make sense? And then on this one, say, sine of 0 is 0, which means you can. Does that make sense? Yes.
Is there any possible chance I get like an extra day?
No.
Or like it's not point this week, so.
It'll probably have to wait. For like, I can go back and change it later, but, I don't have any other to that's next day that you're on.
It's all good.
So we can do it, you just have to tell me when you're going.
I finished the one at the self lab. You're a new thing, right?
Email me.
Okay. You want like each one or just email you that I finished?
Just say I did some homework. All right, y'all, let's just check your answers real quick. Okay, I want to start with this one. Okay, what is the solution for the antiderivative of e to the x? Okay, e to the x, the antiderivative is still, and which one is shaped like an e to the x graph? Okay, it should be this one. So this is A. Okay, then out of the two that are left, can you just tell me the answers? This one has to be B, right?
That's cheating.
Shut up. I already did it, okay? And then this one, Rebecca, what did we say this one is? This would be E. C? C is correct. And then this one is E. And then, okay, out of the two that look like kind of tricky, okay, this one is clearly a wave. And then this one is clearly a wave. Okay, remember, you can tell the difference if you plug in 0. The cosine of 0. Okay, the cosine of 0 is 1, and I can see that this one starts uphill versus this one is sine because I have flats at 0. Okay, so the sine of 0 is 0. That's why this one starts off flat versus the cosine of 0 is 1. This one starts uphill. Okay, so this has to be G. And then this one is F. And then out of the two that are left, these are both the y minus 2's, but bigger than 2 needs to come out positive. So this is your D, and this is your H. Can you do it?
Yeah.
Okay. All right. I want you to still not do the level 2's off last time's homework. We'll hit a couple of those next spots.
Rank the level 1 to
If you did all the level, you could do the tangent line one, but, and then you have the slope field homework that's like 8 questions. Okay?
Goodbye.